So I just thought I'd. Oh, go.
Welcome everyone. Today we're starting with Brown Bag done by Andy about drones. So let's get it started.
So we've only got half an hour, so this is going to be like really quick. So I thought I'd quickly rush through how Quadcopter works and then the parts that you need, and then if there's any questions we can drill into any exciting things. Personally, I find the hardware stuff more interesting because I'm a software guy and I spend all my day doing software, so I actually really like the hardware side of it as well, so I'll probably talk a bit more about that. But right, so has anyone flown a drone before? What sort of drone? Oh, I know what you've flown. DJI? Yeah, that's a drone. Okay, so firstly, there's like what sort of drones are we talking about? So like DJI drones, and the most common, or what most people think of as drones, are for like filming and taking photos. So they're kind of quite big. They're bigger than these ones. They are slower. They're stable. They have GPSs in them. They have accelerometers in them, so they can like control themselves. They have gimbals with video, stabilized gimbals, so that when the quadcopter turns like this, the camera remains stable. Those are the ones that people use for spying through the windows. These ones, like, they have a very low-res camera, so it's not high-definition camera like you get on the Phantom ones. The whole idea is the camera's fixed, okay, and this camera is connected through to goggles that I wear, that the pilot wears, and so you want your camera fixed because that's the only way you can kind of tell the angle of the aircraft in the air, and that's like the most important thing. So you don't want your camera like moving, you want it fixed. And the other thing, these things go pretty fast. So this one, if you put a 5S battery, you're talking like 0 to 100 in about 1.5 seconds, top speed of probably about 150 k's. So as far as aircraft go, they're pretty slow, but they're still pretty quick. So yeah, so those are the drones. These are racing drones. You know, they are cheap. Each drone's probably only about $350, and the other stuff's a bit more. So let's get into how it works. And I thought I'd start with like the battery. So these are basically the batteries. If you haven't seen what a lithium polymer battery is, please be gentle with that. Don't drop it. Don't spike it or anything. It will explode and catch fire and probably hurt you. So just gently pass it around. They are very, very powerful little batteries. You can get like 100 amps out of that, you know, which is probably enough to kill a few people. And they are a little bit volatile, so you have to take care of them. But you know, that's kind of the price you pay. Battery is about $50. Yep. No, you buy them from like specialist RC hobby stores mainly. Yep. So the battery basically feeds into power management. Now power management is quite an important thing in a drone because so you've got all this power coming in, and it'll be running at like 16 volts or 20 volts depending on what battery you've got. The little flight controller computer runs at 5 volts, okay, and the cameras run at 12 volts. They're very sensitive little bits of equipment, so you have to have good you have to have, first of all, voltage regulators that drop the voltage down to 5 volts, and you need filters to clean the power so that it's clean as it goes into the flight controller. So that I knew nothing about that when I started building drones, and I'll tell you why it's important when we get to video. That's why it's important. So clean power means a smooth power supply. So if you can imagine, when we look at how motors work, basically the motor controller is reversing all this energy very quickly, like positive, negative, and that creates a lot of interference, electromagnetic interference around all the cables, which can interfere with your video signal. So if you're running your video cable next to one of your power cables going to the motors, you're going to get a lot of interference because the magnetic field generated by the electricity is going to go through the other wire and create a current and create interference. So that's really important. So you need to think about power management. Because the power management basically sends as much energy as it can to these ESCs. Now an ESC is an electronic speed controller or a motor controller, okay, and its job is to basically control the motors, okay, and each motor is a brushless motor. Let's just have a quick look because this is really cool. It's amazing. There's a couple of motors flying around. You can pull them apart. Has everyone seen these? So there's no moving parts inside a motor. It's really amazing, and this is why electric cars are so easy to run. So how does it work? So do you guys know how when you have two magnets, if you put the positive to the positive, they repel, and positive and negative, they attract? Okay, so basically on the inside ring, you'll see like about 12 electromagnets. So an electromagnet is a magnet that you can control with electricity. So you can reverse it really quickly with depending, because the magnetic field is actually generated by that coil. So you'll see a coil, lots of little coils around here. Okay, the magnets on the outside are just normal magnets. Okay, so as the motor's turning this way, basically, let's say this is the positive and this is the negative side of the battery. Okay, so when the motor's in this position, it switches the current so that we've got positive charge here. Sorry, a negative charge, and when there's negatives and positive, it attracts. Okay, that will bring this magnet over to this position here, and when it gets about to that position, it switches the polarity of this to positive. Okay, it probably does it when it gets more past here, right? Because this is the positive end, and then that repels, poof, repels that little magnet further that way. Okay, so the electronic speed controller is a little microprocessor. Okay, and it basically gets told by the flight controller, please run the engine at this speed. Okay, and so it has to work out, so this is basically like a ground wire, and these are two current wires, and it basically sends current down that wire or that wire to switch it. Now, if you do a few calculations, so the motors spin at about 20,000 RPM. So let's just, if we go, so let's say they're doing 20,000 RPM. I think there's about 12 magnets. So this is happening like 12 times, so if we times that by 12. So it's like 240,000 transactions a minute. Let's divide that by 60. You're getting about 4,000 changes of current every second. Okay, so that's a lot. And the precision of where it changes that is really important. It's just like the timing in an internal combustion motor. It's really important. The time that switches is really critical. And so that's some of the advancements that's happened in ESCs. So the really cool thing about this hobby is you get to see how quickly technology goes. Okay, so just ESCs. Now, I think I've got one somewhere. They're really small. That's an ESC, so you can pass it around and have a look at it. So on there's the microprocessor that's doing all this. So in the last year, they started off being 8-bit, then they went to 16-bit, now they're 32-bit microprocessors. Why does that make a difference? Because they're able to calculate with much more precision when to turn that on and off, and that really affects the efficiency of the motors. The protocol between the ESC and the flight controller is also upgraded. The flight controller used to tell the ESC about, when I started, about 150 times a second it would give it a new speed. Now it does it about 2,000 times a second. Okay, so it's just amazing how much. And the other thing, the latest ESCs now provide telemetry back to the flight controller and back to your transmitter and your goggles with things like temperature, internal temperature of the ESC, amperage that each motor is using, RPM of each motor, and all that sort of stuff. All of that data can be fed back to your radio via telemetry at 400 baud. Okay, and this is like 1.5 kilometers away. So that's you've got a 400,000 baud connection, 400,000 baud connection, 400 kilobaud connection, basically just pumping data back to your radio, which you can then send from your radio to a computer to do flight control or whatever you want. So it's pretty cool. I thought I'd digress badly in this, and I am.
What does the ESC stand for?
Electronic speed controller. Yep. And so each one you can basically connect to these, update the firmware. The firmware is open source. Oops. There's about 2 or 3 different open source projects. I'll give you links at the end. Like they're on GitHub. The firmware for these is on GitHub, and you can go and download it, and then you can configure it. So there's all configuration software and software just for the ESCs. Okay. flight controller. So flight controller, this is where all the kind of really important stuff does. So the flight controller has two main bits of equipment, the accelerometer and the gyro. Okay, so you guys know what a gyro is. Your phone has an accelerometer and a gyro. So they do two different jobs. An accelerometer measures basically gravity. So it's used to determine if something's level. And it can tell you the angle at which you are sitting. It cannot tell you the rate of change that you're changing that angle. It can just tell you the angle. The gyro tells you the rate of change. Okay, so it actually says you are spinning at, like, 3 revolutions a second, whereas the accelerometer is just like, okay. So the most important thing is the gyro, okay, because the flight controller is basically doing one main job. It is receiving commands from your radio. So as you're flying it, you're basically using your radio to point it in whatever direction you want. So it's receiving commands from you, so you're telling it what to do. It's receiving data from the gyro and the accelerometer, so it knows not only what position the gyro is in, but what's the current rate of change in 6 axes. So that way, sorry, 3 axes. That way, and that way. X, Y, and Z. It does calculations based using what's called a PID. So a PID loop is like your speed controller in your car, your cruise control. That's a PID loop. Okay, PID loop is responsible for making something that's variable kind of center in on a target. Okay, so your cruise control will make you go faster if you're sort of slower, and it will the slower you are from your desired speed, the more power it will give, right? And as you go over the speed, it will reduce power. So that's basically what a PID loop does, and the flight controller applies a PID loop to work out how much speed to give to these motors, because that's, probably should have started with that. That's basically how it controls the position of the drone. So if you want your drone to spin this way, you increase the speed of these two props here and it spins like that. Yeah. That way if you want to spin it this way, you add power to the back props. Okay, so that's quite easy. How do you get it to turn like that? Okay, so if you look at the props here, we've got motors 1, 2, 3, 4. You'll see 2 of them rotate anti-clockwise, these 2. Okay, and they're balanced diagonally because they're kind of balanced. And these 2 go the opposite direction, clockwise. So if you remember like torque and all that sort of thing, so if I want to spin it this way, I can proportionally slow down these 2 motors and increase these 2 motors, and the torque will make it rotate that way. So that flight controller is doing a lot of calculations. Let's plug into, oh, hang on, before we plug in. So that's basically what this does. Now, I tend not to use an accelerometer when I'm flying. I just disable it because the only time the flight controller needs to know exactly what attitude or angle the aircraft is if the flight controller actually wants to be doing autopilot. And I don't fly these on autopilot. I fly manually with me flying. Okay, this one here, this is like a long range one that so this has got a GPS, accelerometer, and a barometer, so it can tell the altitude. And this thing can do all the stuff that a DJI it can autonomously fly. You can give it routes and it will go there and turn around and come back and all that sort of stuff. It doesn't have a camera with a gimbal though, so that's about all it doesn't have. Okay, so we've talked about the battery, energy going to the power management, which distributes it, the flight controller doing all the work, your radios, what you're sending your commands. The only other thing we've got left is the video. So these guys produce a video feed, and what we'll do is we'll actually plug in. Now, the really important thing about this video is it's optimized for latency, right? When you're flying at 100 k's an hour, trying to fly through a gate or tree branches or whatever, you don't want there to be any delay between what happening and you seeing, you giving a command, that command going up to the drone, the flight controller making the calculations and changing the motors. You want that to be as small as possible, obviously, so you can fly and control it. So let's just plug in. So we've got that, and you guys can actually have a look. What we'll do is we'll plug this guy in. So I'm plugging this one in, and it's got no motors on. Okay, so never ever plug a drone inside on, or plug your battery on inside with your props on. Safety first. Oh. Okay, I forgot an important piece of the puzzle. I'm repairing this drone. I had to replace the flight controller because I broke it in a crash. That's the flight controller floating around that was in here. Okay, so that tune, if you want, you can customize that because it's all open source. And there's a guy that customized it to be like a Star Wars theme song. When it like booted up. It's quite funny. So here you go, pass this around. So just hold it with 2 hands, just don't drop it please. Okay, so what we've got here is this little camera here. So this little camera, that's the little camera there. This is basically, I've plugged it in. This is the video antenna, this big orange thing here, okay, and that's plugged into this video transmitter. Yeah, come in. We're just talking about drones. Cool. Now the really important thing about the video is, I think that you were asking some questions about how it gets, like how does it get there so quickly? So it's not digital, it's analog. And like these cameras are all, that's the main selling point. They sell the cameras and the video transmitters and the goggles based on like how quick they are in the latency. So latency comes from a couple of sources. First of all, your camera. Okay, it's basically got to convert that digital information into an analog signal, so there's a bit of latency there. That pretty much it's all analog at that point, so it's going through the transmitter, so there's virtually zero latency. By the time it gets to your goggles, it comes into the antenna, and it's still analog at this time. It then gets converted to a digital signal to display on the screens, and there's a bit of latency there. So I've measured the latency on my setups, and they're about between 30 and 40 milliseconds of latency from the video. And how do I measure that? I basically put my stopwatch on, put it in front of the camera, put my goggles there, got another video camera, turned on the stopwatch and recorded it. And so then I could see the stopwatch on my phone and the stopwatch on my goggles, and I could see that it was about 30 or 40 milliseconds behind, which is not bad. It's pretty good. You don't want probably more than 50, 100. Like you probably can't fly it because it's just too slow. Okay, so that, and then more latency obviously comes in from your radio. So your radio is sending up commands. This one at a rate of either 150 commands a second or 50 commands a second or 150 commands a second. Okay, so you've got, if you're flying at, usually I fly at like 50 hertz, so that's like what is that? 1/50th of a second, just from the latency, just from my command to the flight controller. So that's why latency in your goggles is really important, because if you're already 50 milliseconds behind, by the time your brain reacts and puts a command in, there's another sort of 20, 30 milliseconds to this, and then the flight controller's got to do its thing. And so it's all about like shortening that cycle so that you can like fly as accurately as you can. Right, so let's plug these in and just have a quick look at some of the software. Is there any questions on any of that?
How do you like put the code onto the flight controller?
Oh, cool.
It's on Wi-Fi.
Okay, so let's do that. Where's that little flight controller? Oh, no, the new one I put, where's that little bag go? So let's plug this flight controller in. Just need my USB cable. So it's by USB, it's by serial connection. So you can choose to use either USB or Bluetooth. You can put a little Bluetooth module on there and just attach it to the serial port, and then you can do it wirelessly. But Bluetooth modules weigh 5 grams, which is quite a bit. So I prefer just to plug in on these ones, because weight is obviously critical, and you know, 5 grams doesn't sound like much, but when you've like all up weight of about 350 grams, you know, that's like, you know, almost over 1%, which is quite a bit.
What language is it?
Oh, actually, I don't want to. So this is C. So the GitHub. So I'm going to be I'm going to be using a firmware called Betaflight, which is here. So you can see I've connected. You can see little lights flashing. So I'm now connected to that, and now I'm able to. From here, I can actually go to the firmware flasher and select the firmware version, choose the board, and download, and that'll update the firmware. Okay, so I've already done that here, so I should just be able to connect. Right, hang on, let me just disconnect. I've actually put a different firmware on there, so that's incompatible. Let's just go back to this one. Okay, so it's now connected up, and the first thing you can do is move that. Oh, that's not actually connected up. Why isn't that connected up? Might have. Let's get one of these guys. Okay, I'm not sure why that's not. Normally what you see is as you rotate this, you actually see it kind of happening in real time just to make sure that you're connected. So there is a ton load of settings that you can do, but usually like the default settings these days fly really well. But what you have to do is you first of all have to come in and like this board's got 3 or 4 serial ports, so you say, well, you know, my serial radio is connected to this one. My camera and video transmitter connect to this one for control. Configuration, so this is, I'll just go through this pretty quickly, but this is where you sort of specify like how the flight controller talks to the ESC. There's various different protocols. Okay, all those protocols have basically, only the top 3 existed when I started, and all those new ones have been developed in the last 12 months by open source dudes just wanting to make things better. It's amazing. You can have various different type of quadcopters, quadcopter, tricopter, hexcopter, octocopter, flying wing. So this flight controller can pretty much fly anything.
What's a flying wing?
A flying wing's just a fixed wing aircraft, but you know the ones that are just wings, like the stealth bomber. Yeah. So there's no fuselage; it's just a wing. They're pretty popular. This here is basically gyro update frequency. How quickly is it updating? So I've got it set to 8 kilohertz, which is 8,000 times a second. When I used to run at 1 kilohertz. Now I'm running at 8. In the new flight controllers, you can go up to 32,000 times a second. It's quite amazing. And then this PID loop, so that's how often it's reading from the gyro. Yep.
So this is based on the components you put together, right? Let's say your flight controller operates in one speed, and your ECS and other stuff. You have to make sure that this talks on the same frequency.
Yes. So generally, what happens? Most of the new stuff that you buy supports all of these things. But yeah, if you buy a new flight controller and you've got an ESC sitting in your drawer from a year ago, you probably won't be able to run that at D-Shot 600 or D-Shot 1200. You'll probably have to go back to one of these older protocols. Yep. But they still do the job. They're just slower. That's pretty much all it is. This is where you define your receiver, so you can get all sorts of different types of receivers. There's like 5 different brands. The one that I'm running is it's all open source software, so the software that runs in here is also on GitHub. And have you heard of Lua script? It's like a scripting language. You can write Lua script code for your flight controller as well to do things like, autopilot sort of assistant stuff like that. Other features, there's all sorts of other features. Okay, so the other interesting thing here is, one important thing is fail-safe. So what happens if you lose your connection to your radio and your drone? Bye-bye drone. Okay, so you have a fail-safe. So what fail-safe does is there's a couple of options you can put in here. You can say, well, when a fail-safe procedure is initiated by this losing contact with the drone. Okay, so if the connection is lost for like half a second, it waits for another, I think, half a second. You can configure that, and then it goes into fail-safe mode. And so I've configured it just to drop. Kill engines, I just want it to drop out of the sky, because to me that's the safest thing it can do. If there's people around, I'd rather the props were not spinning than it's spinning when it's trying to land. There's no GPS, there's no accelerometer, so this thing can't do anything anyway. So the only option is just drop. You can land if you have an accelerometer. It will attempt to level itself and then slow down and land. And when it hits the ground, it senses that and it'll turn the engine off. But like if someone's standing there, you know, you could hurt them.
You can make it sound later.
Yeah, you probably could. That's really good idea, like a siren, whoop, 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 so that people below move away. Yeah, that's a great idea. Yeah. So this is where some of the sort of interesting and fun stuff's happening. This is where you can actually configure your PID loop, and this is where, like, once you start flying, you kind of, you know, you might want your copter to behave slightly differently. You want it to turn sharper or whatever. But see this number here? This is like, if I adjust these things, like this number here, this 840. So this is the maximum velocity per second. So let's talk a little bit how you control these things. So basically, this stick here controls the attitude of the aircraft. That's all it does. Okay, so let's just unplug this. Oh no, I'll leave that one plugged in. Okay, so when you take off, it's level, right? So there's two modes to flight. There's what's called angle mode and what's called rate mode. And there's lots of different names. Okay, so rate mode is basically your stick. If you put your stick full forward, you are saying spin at the maximum velocity, 840 degrees per second. Okay, so if I push my stick forward and hold it forward, the copter's going to basically do this motion here. It's a bit hard. 840 degrees per second, so about almost 3 revs a second. If I just put it a little bit forward, it'll obviously go very slow, but it will continue to go. Okay. When I center the stick, it stops and it just locks in. So if I push the stick a little bit forward, like this, and then take my hand off the stick so it centers, the quadcopter, using the gyro, will lock itself into that position. And what happens when it's in that position? It goes forward. Okay, so that's why you may have noticed the camera on these is at an angle. Okay, because if you're level, like when you're flying, you're normally at that angle. So when you're flying, you want your camera to be, I fly mine at 30 degrees. So when I'm cruising at 30 degrees, the horizon's level. And you pretty much use that to adjust your speed that you're flying at. So if you're racing, you chuck it up to 60 degrees, and then when the horizon's level, it's like that. And it's obviously going fast, much faster. And you need much more throttle. Like you basically need full throttle, otherwise it sort of goes down like that. So the other thing is, so basically you can control that way, and then you use this stick here to control that way. And so I've configured them all to be 840. Some people fly at 1200, some people fly at 600. I fly with all mine even. I just sort of like that. And you see this graph over here? That one. So it's kind of like, it's not a line. So I want when I'm flying like close to the middle of the stick, I want it to be really sensitive. Okay, so that's why it's smoothed out like that. And then if I want to like do a flip really quickly, I can just like yank it to the right. But in the middle, I want it to be quite a bit more sensitive. So if you configure this graph to be like a straight line, it means that it's as sensitive there as it is up there. But when you're flying, you're usually only doing quite sensitive movements. And then if you want to do a flip or a roll, that's when you like yank it over that way or forward or back. No. So you can go and like search, videos, like on drone racing era. Or I didn't think I'd just show you a bunch of videos today, because like otherwise we could sit here for 10 minutes just watching videos, and you can go and YouTube them. But that's so. I think that's about it. Like, we've covered all the parts that you need, how they all work. I haven't covered I was going to like provide a shopping list, but and I could. The thing is, shopping list is probably going to be outdated in about 3 months, so like you'd have to go and like buy it now, basically. And if you want to get into it, there's like a few other things that really help. So obviously, we've talked about all the software here, so you can learn how to configure, and that's all quite easy to learn. There's YouTube videos and that. The really hardest thing to learn is how to fly it. Okay, like that takes a bit of time, but luckily there's simulators. So you literally plug your radio into your computer. You can either use your screen or you can plug your goggles into your computer as well and get like the full immersive experience, and then you practice. And I probably put in, I don't know, so there's one on Steam called Liftoff. That's a really good simulator, and I don't know, I probably put in about 30 or 40 hours into that before I even really felt comfortable taking my first drone out for a flight, and then I nearly lost it on the first flight anyway. So you want to like train with that before you fly, and also you probably want to build two. Okay, but when you like build one, and you're going to crash it, and then like you got to wait for parts, and so you can't fly for like a month, and then you put it together, and then you've forgotten how to fly. It's like, so get two, and like you only need one of these, and you only need one goggles. But you can, if you do get into it, like be prepared to rebuild your drone at least every couple of once a month or so. It depends what you do. Like if you're flying and you're learning to fly and you're trying to like, fly fast and do tricks and loops and that and fly around trees, it's inevitable that you like, hit the ground, you hit a tree, you hit a rugby post, and things break. But the good thing is all these parts are cheap, right? So like I smacked into you can actually see. This drone here, I smacked into a rugby post like pretty much at full speed, and it smashed the lens of my camera, and it kind of cracked the top carbon fiber, broke a screw, broke the battery off, and broke that flight controller. So I was like, ugh. But the flight controller was like $50, and the camera was like $30. So it's not like the end of the world. But the big thing is it's like several hours of work to like pull it apart and resolder it all in and get it going again. Is there any other questions?
About interference.
Oh yeah.
So like you configure how your joystick talks to the drone, right? If other people are using another one close to it, can they interfere with you?
Yeah, good question. So these radios, it's all digital. And all the protocols are designed for having multiple radios simultaneously operating in the same space. So when I first build the drone, I do what's called binding. I bind that receiver to this transmitter, and it uses, like, I don't know how it works under the hood, but I'm presuming there's some sort of like secret that it shares with it, and there may be a bit of cryptography to confirm or something, but you can have like multiple pilots using on the same frequency, like up to 100, or more, flying at the same time.
Does that actually increase that?
No, it doesn't. It doesn't. No, it doesn't. Yeah. So it operates in the 2.4 gigahertz band, but there's ACCS, automatic something, and it's basically continuously switching frequencies, and and looking for clear frequencies and switching to that, like all the time, constantly changing. So if there's too much interference, it's just automatically, and it just does this, like it just works. I've never had a problem with that. You do get interference with video. So in video, there's only about 40 channels that you can use on the 5.8. So they run at 5.8 gigahertz, so they don't interfere with your radio. And there's only about 40 channels. So if you have someone else turn on their drone and it's on a similar or near frequency, your video might get interfered with, and it might be completely cut off. So they have, these video transmitters have different power bands, and you can configure them via your goggles and joystick, like as you're flying. I forgot to mention that when you look at the goggles, you can actually, there's like if you go left and up, it brings up like a configuration menu, like settings in your goggles. And in there you can then configure everything. You can change all the stuff I just showed you through your goggles and with your radio, and you can change the frequency and power level of this. So when you turn up like to a race, you make sure that you're running at 25 milliwatts so that when you turn it on, it doesn't like stomp on everyone else. And then when you go to race, you get assigned a frequency, and then you can turn it up to like 600 milliwatts or 200 milliwatts or whatever the rules are, and then and then you can turn it on. But they have to be really careful and manage that, because if someone's racing and someone else chucks on their video transmitter on full power, like they'll lose it, they'll crash, and they'll get really angry and stuff. So.
And what's the criteria for racing? Like quickest around the 100 course?
Yeah. So there's racing, and then there's freestyle, which is like they give you tricks for style, and so it's like freestyle anything versus racing anything. It's like drift racing versus motor racing, kind of thing. Yep. And yeah. The other thing that I learned was like all the interference that you get from inside the circuitry. So my very first drone I built. Everything looked good. The video looked great at home on the bench. Everything looked great. Went to fly, and as soon as I applied the throttle, my video like just got all messed up. And it was because there was too much interference from all my basically the ESCs are what produce the interference, and that interference goes through all of these wires and can affect that power supply. So if the power supply of the transmitter is going up and down like this and is unstable, the transmitter has a really hard job of like transmitting a smooth signal. So you have to do things like think about your power management. Power management usually involves having voltage regulators and capacitors. So a capacitor, its job is to smooth out. So a capacitor is like a mini battery. So you turn it on, it charges up. If your engines like pull a whole lot of energy out of your batteries and the voltage and amps drop, that energy gets released from the capacitor, so it effectively smooths it out. So I chucked on a few capacitors and it was much better.
It looks like most of those parts you just brought. Can you buy even the power management like pre-made?
Yes. No, you can buy a power management board, and actually what's happened is, so my first drone I had a separate power management board and a separate flight controller and like everything separate. Nowadays it's quite popular, like that one that is going around, that's actually got the power management and the flight controller built into the same board. And this one's actually also got the video transmitter on the same board. So this one's kind of got pretty much everything you need except for the video and the ESCs. But I've kind of moved away from that now, because as I learned, now that I broke this and everything's broken.
But in terms of latency, is this better or doesn't matter?
No, it doesn't matter. No difference at all. Yeah, because it's all analog. Oh, so the only other thing that I forgot to explain. Oh wow, how did I forget that? So there's an OSD on-screen display. So when you guys were looking through the video, you may have seen some numbers at the top. Okay, so the video signal from the camera gets fed into the flight controller, and the flight controller overlays textual information onto the video signal and then passes it back to the video transmitter, so that when you're flying you get to see your voltage, your speed, your amperage, your fly time and all that. And that's really important. And then you also have warnings, so you have warnings on your voltage level of your battery, because remember how I said these are a little bit volatile? If you drop these if you basically take too much power out of a lithium battery, it will probably catch on fire. Simple as that. So you have to be very careful that you don't use it too much. So it happened to me once, and what I was just dumb mistake. I was flying. I was quite far away. Ignored my battery warning. Thought, I've got plenty of time. And then by the time I came back, all this plastic was bubbling. And I was like, and the battery was toast. I couldn't charge it again. It was toast. So that was an expensive lesson to learn, because it was like $50 a pop. And normally they last for like probably a good 200 or 300 charging cycles if you look after them. So if you look after it, it kind of lasts. Oh, yep. So about 5 minutes. Yep. So these racing drones aren't designed for endurance; they're designed for speed. So you can fly at 150 k's for about 5 minutes. On like a Phantom, you'll fly for 20 minutes, but you'll only be able to fly at 40 k's. and they can't do loops and flips, and they can't spin it. Like these things are incredible when you see them flying. And maybe we should organise a date where we can go and actually see one flying, because like just seeing something spin at 3 revs a second, like it's really fast. It's really amazing, and just see how stable and rock solid they are flying them. They're really good fun.
How far can they fly?
So about probably with this one. So there's 2 types of radios I use. There's this one, which is probably about 1.5 kilometres, and then I've got a long range radio that I use for that, and that's about 20 kilometres line of sight. Yep. But my video can only go about 3 kilometres. So I can fly about 3 kilometres with that one. But we've just seen there's a new like rev of all the video gear coming out that runs at a lower frequency, so you get more range, and they're talking 10 kilometres. So. Oh, this drone here, so this drone, like not much more, like this drone might be $450 instead of $300, because it's got a GPS, it's got long range radio, and long range video.
How much is the controller?
So the controller, so you can, it's like anything. You can start at about $100. This one was about 150, and then you can go up to like $1,000, but 150 for that. These goggles here, so if you're starting, buy a cheap pair of goggles like this, again, $150. And then if you decide to get into it, these goggles, which are just they're a bit more comfortable. They've got 2 screens instead of 1, so they can do 3D if you want. You can have 2 cameras and do 3D, but I've never tried that. And they just feel more comfortable, and they're a bit easier on the eyes. And that's about $400 if you want to get a pair like that. Yeah. Yep.
So how much have you invested in all of these? A lot.
Yeah.
It's like any hobby. We won't tell you
Sorry?
what. Don't worry.
In the controller, there's so many buttons.
Oh, yeah,
Like,
sure.
what do they all do?
So these lots of buttons. Those are just the 2 main controller ones. So then you have buttons. So generally I have a pre-arming sequence for safety, so I have to pull that button down there, and then flick that up and down to arm. So that's my arming sequence, and that's just my, like that isn't any, I just chose that and configured that because I was comfortable. Because I used to just have this switch, and one day I was getting set up and I had everything ready to go, and I dropped my radio and it landed like that, flicked the switch and the drone went, and somehow this was up and the drone went so I kind of went, oh, so I did that so that just for that reason. So that's those 2. When I'm flying this one, it has, because it's got GPS and it can like do autonomous flying and all that. So I have like a return to home button. So if I panic and get lost and just want it to come home, I just flick that and it'll come home. This one changes the flight modes from like GPS position hold to like sort of manual, and then to like full on manual. This is just beeper. If I get it lost and I'm looking for it in the grass, I just do this and a beeper goes. And this one here, that's a flick switch, so I normally just configure that to, when I turn this on, you've got, so you can do things, it does sound like Syria. So you can get like, you can configure this to give yourself like verbal warnings when things are happening. So if your voltage is coming down, it'll, warning. If you, it can monitor your voltage, your radio link, everything, and it can give you warnings. So this, and so you can just, every time I do that, it just tells me the voltage. It's not hooked up yet, so it's just 0. And there's an SD card in here, so you can like put whatever sound you want. It's all open source. It's really cool. Put whatever sound you want. You can configure all the, like I said, all that telemetry is coming into here, so you can configure this to do quite a lot for you. It's pretty cool.
What do you use that drone for? Is it for racing still, or?
Which one? Yeah, just I don't know. It's just like I just like flying it. I don't use it for anything specific other than seeing basically how far I can fly away. Like, so my goal, I had this little personal goal, which was to be able to sit on Takapuna Beach and fly to the Rangitoto Lighthouse, orbit it, and then fly back, which is 4.1 kilometres, and I can't do that yet. So I can only get about halfway. I can only get about halfway, and then my video starts dropping out.
Do you use your GPS for the rest of the way?
I could, yeah, I could. Yep. So I could program this. Yep. I could program this to fly all the way and back. But yeah, I want to actually be in control.
I wanna see it.
Yeah.
Does that software run off that same one you showed us, the autonomous software in that?
No, so I've got a different firmware on here called iNav, and iNav is so. It's really interesting. So it all started off with a guy called Boris from like Russia somewhere who made the base flight was the first one, and then it forked. This is all on GitHub, and then it forked to clean flight and race flight, and then clean flight was forked to beta flight, and then beta flight was forked to butterflight and iNav. Now, iNav focuses on navigation and autonomous flying. But what they do is they're continually pulling from Betaflight to get all the, like, you know, when new hardware comes out, the Betaflight guys do the drivers and they pull that into iNav for this. Butterflight is interesting. So there's a special type of filter called a Karman filter, which was developed by some Russian so it's basically it's a filter designed to filter the signal from a gyro, and it's a software filter. And Butterflight, everyone was saying on the threads, you got to implement a Karman filter. Now we've got strong enough processors to do a Karman filter. Why aren't we doing Karman filters? And the guys on Betaflight were like, and so someone went, oh well, screw you. They forked it and they implemented this Karman filter, because now the new processors are so much faster. It can do software filtering like that, and it's really advanced software filtering. And like the gyros, you know, the accuracy and smoothness of that information from the flight controller is really critical for obviously controlling like the aircraft. So like the latest, so I'm like running, these are ARM processors in here, I think. So this is called an F4, F7 is the latest one, and you know, so I can, so the F3 was the processor that I first started with, just to give you an idea. So I was running at the PID loop I was running at 1,000 kilohertz, so 1,000 times a second. And on F3, the processor was running at about 60%. You can see the processor utilization on that tool I just showed you. And then when I went to F4, processor utilization went down to about 0.5% running it. So then I put it up to 8 kilohertz, and that's now running at about 50. And then with an F7, it's the same. You put an F7 on, and at 8 kilohertz, the CPU usage is down to like 5%. So you can crank it up to 32, from 8 to 32, and basically it's just processing things faster and faster to get it more and more accurate.
So a faster PID means faster reaction to your commands.
Yes, and smoother. Yeah, which is the key, because it's yep.
What's the advantage of having the analog gyro and the programmable digital gyro? So the gyros are the same, but what I meant was so the gyro sends information into your flight controller, and the flight controller, so the gyro information is quite noisy because there's a lot of vibrations from engines and things. So the gyro might be quite the graph might be sort of like this, and so you want so the flight controller can apply filters to sort of smooth it out. So so it's all digital. It's all digital. Like everything's digital. The only thing that's analog is the video signal back to your goggles. Yeah, it's really cool. Any other questions?
More electrical motors, these motors burn.
Oh, yeah. So I actually spilt beer over the ESC. Yeah, like that's actually honestly what happened. And it destroyed the ESC and the motor. And it was like, bummer. Don't drink and build. And then the other one actually, it just happened. I had extremely badly configured PID loops, like so bad that when it flew, it just started oscillating violently, crashed into the ground, and this motor started smoking. I was like, oh, bummer. But what I'd done is you can configure these switches. When I first started, you'd build it and you'd like take it off, and the thing would be flying horribly. It'd be oscillating and all this, and you had to spend like several hours tuning those PID loops. But now, because the software's got better, like the defaults just fly.
normally. So what I did, and it's really hard to tune the PID loops because you go for a fly, you have to land, and then with your goggles or with the computer you adjust PIDs, and then you take off again and fly. You can't really adjust them in flight. So it's a very slow iteration, and it's just like time consuming. And then this guy came up with this way to adjust them in flight using buttons. And I was like, oh, sweet, so I'm going to do that. And I basically screwed it up, and while I was flying, I left one of these buttons down too long, and one of the values in the PIDs just kept going down, and then it just crashed and burnt out one of the motors. So yeah, because I guess if these, if the signal's going, if the timing of all these gets screwed up, and I don't know, it just went bad.
Like feed profiles and loading.
Yeah, totally. So I back up. So nowadays I don't spend as much time tuning, but yeah, I do, and I kind of know the changes that I make, so it's kind of a bit more natural. But yeah, you back up. So every time, once you've configured it, you back up all the configuration, so that if you need to replace parts, yeah, you've got your backup configurations. All those numbers in there, you just hit the button and it saves it to file, and you just save that away. Yeah. No, it's really it's pretty amazing once you get into it. Just
And you wrote down 4 websites. What's the best one for like beginners to just kind of that I can go and research and try everything?
Yeah, probably those 3.co.nz ones are good. Banggood is sort of good for cheaper parts from China, but low quality, and you have to wait for a bit. And then
mainly just for like reading it.
yeah, RC groups forums. So the biggest one's RC groups. So there's a quadcopter section in RC groups. I didn't add that, but just search RC groups, and there's plenty of stuff there. Like there's actually kit sets that you can buy. So that's what I do for my first one. Instead of trying to figure out all the parts, you can actually buy kits, and so they have all the bits that you need in a box, and you just all you have to do is assemble it. And that's what I'd recommend doing for your first. So you can go to Banggood or any of those places and just buy a kit, and it's got everything. Because otherwise, you have to figure out, does this motor go with this ESC and this thing, and also importantly, does this stack fit inside this frame? Like there's stuff like that. So if you buy a kit, you know that they're all going to fit, and it'll be easier. And I mean, on Banggood, there's kits for like $180, and then all you need to do is go and buy. They usually don't include a radio receiver, so you just have to go and buy that.
What was the name of that firmware again?
Oh, that Betaflight? Yeah, Betaflight.
Do you think you could put this on the open channel like that document?
Yeah, sure. I'll put some more links to the other things I haven't got is a GitHub repo. So those are, if you go to Betaflight GitHub, there's the wiki, and that's also probably the best resource because there's like a huge stack of information on how to configure things and parts, and yeah, big discussions.
Those dudes that like build quadcopters with Arduinos and stuff like that.
Yeah.
How does that differ into building to these components that you use?
So not much. I mean, the components on these, the processors and everything is basically the same as what's on an Arduino.
There's nothing specific about these.
No, it's all, the firm. These have been like custom built for aircraft, right? Because they have a gyro on them. This one has a barometer on it, so it can do the altitude, and so yeah, like it'll be a big struggle to build one on an Arduino.
I still have the argument to it.
Where do you get your parts from?
So I get my parts from a mixture of those, like all those places, and a couple of US sites. I'll add some more links, but yeah, I used to get most of it from Banggood, and then I started noticing that sometimes the quality was a bit shitty. Yeah. Like most of the time they are really good, but every now and again, you'd get a. Yeah, you would, and you get it bad. But on the flip side, they're really good. Like if you have a problem, they'll just take it back and give you a new one. But
How big is the racing community?
so there's like a flight club Facebook group, and so I went to a race at Smails Farm a few weeks ago, and there was maybe like about 20 guys racing, and about another sort of 20 or 30 people watching. Spectators, and it was quite funny because most of the spectators were sitting there with goggles on, just going like this. So it's kind of, yeah, it's like a silent disco. Have you ever been to a silent disco where, you know, everyone's, it was kind of like that, where everyone's kind of going, oh wow, but looking in their goggles. And they have like the pilots and what frequencies they're on, so you can tune your goggles into the pilots, into whatever drone you want.
Did you link that
Yeah.
Facebook page onto the
Yeah, sure. Yep. So,
Any more questions? No? Alright, thanks, Andy.
cool, you're welcome. So on GitHub repos,
Talk
Facebook.
today.
Cool, thank you.
Yeah, so upcoming we have Browback on Golang and functional programming. And if you want to do a Browback, please talk to me, Ashik, Jordan, or Karen. Yeah. Thanks for coming. Or Mark. Yeah. Thanks for coming.
Thanks, Andy.
Cool. Thanks, guys. I'll publish that on the meetup so you can get those links if you want.
Yeah.
Cool. Yep.